Hello students, let us discuss isotopes and isobars in the chapter Structure of Atom. Let us first define isotope. Atoms having same atomic number but the mass number is different are called as isotopes. That means the atoms of same element, that is having the same atomic number, but when there is difference in their mass number, then that atoms are called as isotopes. Let us take an example of isotope of hydrogen, that is protium, deuterium and tritium. When we look at the atomic representation which is given here for these cases, in the case of protium, atomic number is 1 but the mass number is also 1. But in the case of deuterium, 1 is the atomic number, 2 is the mass number. But in the case of tritium, 1 is the atomic number, 3 is the mass number. So when you look at these representation, these are atoms of same element because these all are atoms of hydrogen. But what is the similarity here? The similarity is that these all are hydrogen atoms, but they have different mass numbers. When you look at here, the mass number is different. That is 1 in the case of protium, 2 in the case of deuterium and 3 in the case of tritium. That means these are the atoms of same element, that is hydrogen, but they differ in the mass number. So these are the examples of isotope. That is, this is the example for isotopes of hydrogen. Let us take another example, that is carbon. Carbon in the nature exists in the form of C12, C13, C14. You are already familiar with C12, carbon 12th isotope, which is taken as reference in the finding out the relative atomic masses for the other elements. So here the carbon 12, that is an isotope, carbon 13 is an isotope, carbon 14 is an isotope. So here these having same atomic number, that is 6 is the atomic number, all having 6 number of protons, because the number of protons are same because the atomic number is same. So here the atomic number is same for all these, that is 6. 6 is the atomic number, but they have different mass number. That is, the mass number for here carbon 12 is 12, 13 is the mass number here, 14 is the mass number here. That means they have same atomic number, that is 6, but different mass number, that is 12, 13 and 14 respectively here. So why there is a difference in their number of mass number? That is because there is a difference in the number of neutrons. When you find it out, the number of proton and neutron, because the mass number is actually the sum of protons and neutrons present in the nucleus. So when you find it out in the case of carbon 12, there are 6 number of electron and 6 number of proton, that is, it makes 12. So 12 is the mass number. But in the case of carbon 13, there are 7 number of neutrons and 6 number of proton. So the sum is actually 13. So 13 is the mass number here. But in the case of carbon 14, the number of neutron here it is, that is 8, and the number of proton is 6. So the sum is actually 14 here. So we can say that in isotopes, these are the atoms having similar atomic number but different mass number. So why they have different mass number? Because the number of neutron is different in these, as the number of proton is same here because these are the atoms of same element. That means they have same atomic number. When they have same atomic number, so that means the number of proton will be same. So these have same number of proton. So what is actually differ here? That is neutron is differing. So the number of neutron is differ actually in these atoms. So let us take one more example, that is C chlorine 35, chlorine 37. Here the atomic number is same, that is 17. But what is the difference here? That is the difference in their mass number, that is 35 here and 37 here. So the isotopes are actually differing in the number of neutrons. So how we can define isotope in another way? That is, isotopes are the atoms with same number of proton but different number of neutrons. That means we can define an isotope in this way, that is, these are the atoms having same atomic number but different mass number, and we can also define this in this way, that is, isotopes are the atoms with same number of proton but different number of neutron. So these are the two definitions given for isotopes. As chlorine occurs in the nature in two isotopic forms with the masses 35U and 37U in the ratio 3:1. That means the chlorine existing in the nature in the Cl35 form and Cl37 form. That is 35 is the mass number here and 37 is the mass number here. So it are occurring in the nature in the 3:1 ratio. 3:1 ratio means 75% of chlorine 35 existing and 25% of chlorine 37 existing in the nature. So if 75% of chlorine in the nature having the mass 35 and 25% of chlorine in the nature having mass 20, that is 37. So what will be the mass for the chlorine atom? That is a question arises here. So obviously the question arises, what should we take the mass of chlorine atom? Let us find out that, because in such cases the average atomic masses for chlorine atom should be taken, that is on the basis of the above data. What is the above data here? That is 35U and 37U are the masses of chlorine isotopes existing in the nature 3:1 ratio. 3:1 ratio means 75% is the chlorine 35 existing and 25% of chlorine 37 exist. So on the basis of this, how we find it out the average atomic mass for the chlorine atom? That is 35 into 75 divided by 100, because 75% of chlorine 35. Therefore 35 into Cl, that is 35 into 75 by 100 plus next is the 25% of chlorine 37. That's why 37 into 25 by 100. So when you make this calculation here, after that you will be getting the mass, that is 35.5 U. That's why the atomic masses for chlorine is taken as 35.5 U. But some isotopes have a special properties which find them useful in the various field. That is, isotopes which are useful in the various field, like an isotope of uranium that is used as a fuel in the nuclear reactors. In the nuclear reactor, there is a conversion of energy, that is nuclear energy, into the useful form. So there the isotope of uranium is taken as a fuel. Next, an isotope of cobalt is used in the treatment of cancer. That is one of the most important application of isotope in the medicinal field. And an isotope of iodine is used in the treatment of goiter. So these are the important applications of isotopes in the various field. So after the discussion on isotopes, now let us discuss isobar. Isobar having same mass number but different atomic number. So when you just compare it with the isotope, what is the difference here? In isotope, atomic number is same, mass number is different. But here, mass number is same, but the atomic number is different. So that means if atomic number is different, that means these should be the atoms of different element. That is important. Isobars are the atoms of different element because the atomic number is different here. So let us take one example, that is argon 40, potassium 40, calcium 40. So when you look at here, these three atoms, these are the atoms of different element. Why? Because this is an argon atom, this is a potassium atom, this one is a calcium atom. But what is the similarity in this actually? These all having same mass number, that is 40, which is represented here. They having same mass number, that is 40. But here, as these are the atoms of different element, that means they must have different atomic number. When you look at here, in the case of argon, 18 is the atomic number. In the case of potassium, 19 is the atomic number. And in the case of calcium, 20 is the atomic number. So that means they have a different atomic number, but the mass number is same. So how you define isobar? Isobar can be defined as atoms of different element with different atomic numbers which have same mass number are known as isobars. So that means in isobars, these are the atoms in which the sum of the neutron and proton must be equal. That is, mass number is equal, as here it is 40. Mass number is equal, that means the sum of the proton and neutron, that is actually the mass number. So we can say that the mass number is same, that means the sum of the proton and neutron is same for the atoms. That atoms are called as isobars. So when we compare isotopes and isobar, it is clear from this table, that is, isotopes are the atoms of same element, but isobars are the atoms of different element. Since these are the atoms of same element, so we can say that they have same atomic number. As isobars are the atoms of different element, so we can say that they have different atomic number. As in isotopes, the atomic number is same, but they having different mass number. When you compare it with isobars, isobars have same mass number, but here the mass number is differing. So when you compare these two tables, it is clear from that here the atomic number is same, here the atomic number is different. Here the mass number is different, but here the mass number is same. So as here the atomic number is same, that means the number of proton and electron should be same. But here these are the atoms of different element, that means the number of proton and electron are not same in these cases. So this is the comparative study of isotopes and isobars. These are the most important point in this chapter. So that is what we have discussed about isotopes and isobar in this video, and we have also done a comparative study about isotopes and isobar. So this is all about this video. Have a nice day.